Previously, we saw how there are three types of solutions: isotonic, hypotonic, and hypertonic. Just before I move on to today's lesson, here's a question for you. Can you tell me why it's not enough just to say that the solution is hypertonic? Think about it. Well, it's because hypertonic and hypotonic are relative terms. So you must say what the solution is being compared to. What do you think is the ideal solution type for an animal body cell? Yes, it's the isotonic solution. And this is because in an isotonic environment, there won't be any net water lost or gained by the cells. Now, by the same logic, you may think an isotonic solution is perfect for plant cells too. So, let's try putting a plant cell in one and see what happens. Oh no, the cell has become droopy or flaccid, as a biologist would say. Why did that happen? Well, the net uptake of water was just not enough to make the cell turgid or taut, and so it's flaccid now. But then, what is the ideal solution for plants? Well, plant cells prefer a more hypotonic solution because, as you can see, they have a rigid cell wall that needs the pressure from the extra water inside the cell to stay firm or turgid itself. So now, let's see what will happen after I place this plant cell in a hypotonic solution. And there you have it. The higher water potential in the hypotonic solution as compared to the plant cell's vacuole meant extra water moved into the cell by osmosis. And just like that, we've got ourselves a firm cell with a vacuole that's big and full. Notice how the vacuole now is pushing all the other cell contents, including the cytoplasm, towards the side. Well, that is how a turgid plant cell is, with the cell contents exerting turgor pressure onto the cell wall in this way. The cell wall just ends up exerting the same amount of pressure back onto the cell contents in response, and this prevents too much water from coming in. A biologist would call these stages some very specific names. So remember the words turgor, which is what this phenomenon is called. Do take note that cell turgor is crucial to maintain the shape of non-woody plants and the soft portions of trees and shrubs.